Next, we're going to go through example 1. So earlier in the Concept 5 textbook, or part of the textbook, you're given a problem about Jacques and the coordinates of the flags on the ski hill. He needs to figure out if the coordinates have anything to do with the steepness of the ski hill. How can he figure this out? And so what we're going to do is we're going to calculate the slope of the ski hill that he's on. So the coordinates that he saw while skiing are as follows. 98, 60, and 82, 124. Now, if you really prefer the visual and thinking about it as rise over run visually, you'd have to graph these points to figure out the slope. Or we can have a little bit more algebra approach to it, and we can label the first point as x1 and y1, and the second point as x2 and y2, and use our slope formula to calculate the steepness of this hill. So I've labeled the first ordered pair as x1, y1, and then I've labeled the second ordered pair as x2, y2. Now, whenever you're writing out ordered pairs, your x number is always written first and your y number is always written second. A good way I always remember that is it goes in alphabetical order. X comes before y in the alphabet, so when you're writing an ordered pair, x comes before y. Applying this to our slope formula, which is the difference between your y values divided by the difference of your x values, I am going to take 124 minus 60 divided by 82 minus 98. It's important that the first number you write using this formula for your numerator and denominator both come from the same ordered pair. So what I mean by that is 124 is paired with 82 in this point above. And so notice that I have each of those numbers written first in my numerator and denominator, and I have the other numbers written second. So it's important that that order is consistent. If I write 124 first in my numerator, I have to write that point's x value first in my denominator as well. It's really important to stay consistent there. So doing 124 minus 60 is 64. Doing 82 minus 98 is negative 16. And dividing those, we get negative 4. So that means our slope, or m, equals negative 4. So we know that this ski hill has a negative slope, so it's decreasing, so he's going downhill, and it's a slope of negative 4. Now let's look at example 2. So example 2, it says, what is the slope of the straight line shown on the following graph? So I'm going to take a moment to sketch this graph, and so I would recommend following along with me and doing that in your notes as well. I probably don't need to go quite so far that way. Right, so I'm noticing if I were to plot some of these points, there's a point at negative 2 on the y-axis, and there's a point here at 3 on the x-axis, so I'm going to connect these. And you could follow this along in your textbook versus drawing it out in your notes, but just in case you don't have the textbook, it might be nice to have a physical copy of this that you could write on in your notebook. So you could go through and find 2 points on this line, just like we did in the last example problem, and find slope that way, but I want to show you how you can use the visual of rise over run and using the graph to your advantage to find slope. So if I'm given a graph, the first thing I'm going to do is find 2 really nice points on my graph. So 2 really nice points that I have found are the x and y intercepts. And I'm going to think, to get from one point to the next, how far do I need to go up and how far do I need to go over to get to the next point? And so I'm going to start with this point here that's furthest to the left that I've chosen. And in order to get from this point to the next, I first need to rise 2 jumps and run in a positive direction 3 jumps. So I have to rise 2, I have to go up 2, and then I have to run to the right 3, both in a positive direction. So when I'm thinking about slope being rise over run, my rise is I have to go up 2, and my run is I have to go in a positive direction of 3. So I end up with a slope of 2/3. Now their visual is a little different because they wrote the visual underneath the line, but I wrote it above the line. Notice that whichever one makes the most sense to you is great because it works both ways. All right, let's take a look at example 3. So example 3, we are given the equation, or no, we're given 2 points on example 3, I'm sorry. It says, what is the slope of the line passing through the points A being negative 610 and B being negative 2, 7? You could draw a picture of this graph and calculate rise over run by creating a visual, or you can use the formula. I'm going to use the formula here, but know that you could create a visual like we did in example 2 and count it out that way, and that would be fine. Using the formula of y2 minus y1 over x2 minus x1, B is my second point, so the y-coordinate in my second point is 7, minus the y-coordinate in my first point is 10. The x-coordinate in my second point is negative 2, so I'm going to start with that in the denominator, minus the x-coordinate in my first point is negative 6. Be really careful with these negatives, okay? Making sure that you're not accidentally dropping the negative out. Making sure that you're still keeping that negative sign there with your number. 7 minus 10 is negative 3. Negative 2 minus 6. We need to remember that that double negative here in the middle really turns into like a plus sign. So it's really like we have negative 2 plus 6, which is 4. And so we end up with negative 3/4, and that's as simplified as it gets, and so that is our slope.